For anyone who may be curious, this is my rig. I'll show you how it works. We just got a walk behind lawnmower transmission there that's engaged all the time, and then when you pull the clutch lever, it tightens this belt, and when it tightens the belt, the engine spins the transmission and away you go. It's welded together with just a couple old scrap pieces of metal. The steering's all held together by bolts with cotter pins through them. And it does have a few nice pieces like these steering joints. But in here it's just pinned together. Not a lot to it really. It's kind of messed up right now. I tried doing a jump on it. If you want to see the jump that I tried, you can check out the link in the description. Anyway, if you look here, that wheel is pointing straight, and this wheel not so much straight anymore. So what happened, if you take a look here, these pins are bent. That one's bent. That one's quite bent as well. I could just bend them back, I suppose. And then there's the steering shaft, or the handlebars, whatever you want to call it. They're bent up pretty good. Look at the debris up here. The rewind I've taken off. It's yeah, it was damaged. I don't know if I hit it with my knee or what, but yeah, it got crunched, so it's not working. And then the back wheel here, we snapped the back wheel right off almost, just hanging on by a few little threads there. Anyway, got a few little bends in her, but pretty incredible that it took it at all, really. Working on this, I remembered that my girlfriend's windshield washer pump isn't working. That is definitely not a satisfactory result. We will have to get a new washer pump and install it. So I guess that'll be a video. So I've taken apart this water pump, and I figured I would give a brief explanation on how it works. So we have the engine. I don't know if you guys can see it, but the engine turns the input on the pump here, and when that turns, the pistons go in and out. These are not pistons, these are just brass sleeves. The pistons go in and out shaft turns about 3,000 RPM, give or take, and when it travels in and out, it's sitting like this, and so those pistons go in and out of these holes. There's 3 holes there that the pistons go in. So we have these secondary seals, I'm not sure what they are actually called, and we have these seals. So 2 sets of seals go in around the pistons to contain the water pressure. Now the water from the house comes in through this. Before it goes into any of these chambers, it goes through these little check valves, and I have one of them part here. There's 6 in total, 3 on the inlet and 3 on the outlet. So basically all these check valves is a little seat, the valve itself, which is a little plate, a spring, and then a little plastic retainer that just holds everything together. And so what happens is the water flow can very easily pass through this way. In order to come in through this way, it just compresses the spring and the water goes in past. So the water from the house comes in through these 3 there's 3 valves on the inlet side, and it passes through them, but it can't pass back through because when it tries to pass back through, it pushes against the plate and seals itself. Where these check valves go, actually these ones, which are the same thing, they're just a little different format. I'll put it together now as I'm talking. One goes in here. You can see the water comes in from the house here, and it actually has to go through that valve. And so what happens, it goes through that valve and into this void. So we've got these 3 valves. So what happens is the water comes in from the house, goes through these check valves into these cylinders, and when the piston comes down, it pushes the water out through an orifice in the bottom. This orifice leads to this passageway. There's a short passageway from here to here, and there's another passageway from this cylinder to this chamber. We have more of these check valves which go in like so, and when one piston is pushing, I don't know if you guys notice, but when one piston is pushing, the other one is actually sucking. So to stop it from just cycling the water in a circle, when the water gets pushed from this cylinder out through into this chamber here, it gets pushed through a check valve. So then when the water gets pushed through into this one, it doesn't just go back through into this side. There's a check valve that is holding the water pressure on the hose side or your wand side. Then we've got these brass caps that go on and hold everything together. So just a short recap of what I've talked about so far. We'll talk about this as though it only had one piston to make it easier to understand. So the water comes in from the house, goes through the check valve into the cylinder. So the piston comes up and the water fills the cylinder. When the piston goes down, it can't go back through the check valve and into the house, so it goes out into this chamber and out your hose. There's actually 3 pistons working simultaneously, so you get a more steady stream of water instead of pulsating. But if you do look closely, or if you have ever used one of these pressure washers, you will notice that it does pulse. So there's one more problem that these pumps all have to deal with, and that is that water can't be compressed. So unlike an air compressor, you don't build up water in a tank and then release it when you need it. You have a hose coming in and it's supply on demand. So when you pull the trigger, the pump pumps the water out. The only thing is that the pump needs to continue running all the time. So even though you're no longer spraying water, the motor is still turning, rather the engine is still turning, and the pistons are still going in and out. So that pressure has to go somewhere. Otherwise, the system would either break or the engine would just lock up and stall. So the way that they deal with this, I'm not sure how much of this I'll actually be able to show, but this little device here is what they call an unloader valve. And it basically has a spring inside of it. It's not terribly complicated. A spring, a little brass cup, and the brass cup pushes on a piston. So we have a piston here. It doesn't want to come out, but yeah, there we go. We've got this piston with a little rounded end on it. And that goes all together like so, and it screws in here. The unloader valve has this little round tip that is spring loaded, and it seats in there, and you can actually see the passage kind of here. So you've got your manifold that goes out to the hose, and it loops back and goes in. And if you remember from earlier, these valves are where the house water comes in. So what happens is when you back off of the trigger and stop spraying water, the pump pumps the water in through, and when it does that, it bypasses the unloader here, so it comes through the manifold and just goes back in. Basically, when you back off of the trigger, the water just keeps going in a circle. It keeps looping around and around and around. When you pull the trigger and demand water again, the water stops bypassing the circuit and goes out the hose. Alright, so now that I have it back together, I'll go over it once again quickly and explain basically how it works. So we've got the house water supply coming in through here. We've got our pistons and cylinders located in these locations. We've got check valves here, here, and here. And we've got 3 more check valves here, here, and here. This is the outlet where the water goes out, and this is the bypass or unloader valve. So what happens, the motor is turning, pushing the pistons in and out. The house water supply comes in, goes through the check valve and into the cylinders. So it goes through the 3 check valves and into the 3 cylinders. So each piston pushes the water and it goes through a check valve into the manifold. When you have the lever on your wand depressed and it is spraying water, each time the piston pumps, the water sprays out through your nozzle. And that's why you get a pulsating spray. The engine is turning at about 3,000 RPM, and there are 3 pulses per revolution. So it does pulse very quickly. Now when you let go of the trigger on your wand, the water is shut off. So no more water can go out through here. And the motor is still running, the engine is still running. So that means the pistons are still pushing water. So what happens is when the piston pushes the water and this is plugged, the water reroutes and goes through the unloader valve, which is here, and we can't see it very well now that it's all together, but it comes through and back into to the house water supply, and it basically keeps looping around. So that will just about do it for today. If anybody wants to see me tear into the mechanical side of this pump, I want an explanation of how that works, let me know. Keep following my videos because I'll probably be tearing this one apart. It sounds like it might have a noisy bearing. So yeah, I may tear that apart anyway, even if nobody asks for it. But anyway, that's it for today, so I will see you guys next time.